Alright, Locomotive Division, General Motors Corporation, Maintenance Instructions 1753, Revision C, Alignment of Locomotive Rotating Equipment, Introduction Machines and rotating power systems such as the diesel electric locomotive generally connected together, meaning with direct coupling or shaft of the coupling arrangement. Proper alignment of the interconnected machines is necessary for the number of the reasons. Mechanical system precise alignment reduces the stress shaft of the couplings, thereby minimizing vibration, unequal bearing loads, bending of the shaft, electrical rotating, such as the motors and generators require special consideration because of the critical position of rotor relative to the state of both axial radial axle positions. Important to avoid rotor thrust loads on end bearings. The radial position of the air gap equalization is necessary for the proper interaction. Rotor and stator fields, which affects electrical characteristics. This maintenance instruction deals with the alignment of the both mechanical and electrical components of the locomotive power system. Alignment in general. Although alignment of the rotating system is usually performed with respect to the coupling strip, for the real concern with alignment of the shaft, generally more convenient to attach a gauge indicators on the coupling face of the edge of the flywheel than the position directly on the machine shaft. Particularly true with dealing with large machines such as engine, traction generators, etc., where main shaft is physically inaccessible within a rotating system with a measurement of edge variations on a flywheel coupling face is rotated to orientation of shaft center with a respective reference point of the other shaft of the central line. Some fixed surfaces such as generator housing, locomotive deck, in this way indicator reading on the edge of the flywheel or coupling are valid means of determination. Shaft alignment. The dimensions. Alignment of the techniques make use of a specific set of the terms applied with the dealing rotating system. Figure 1 illustrates 3 of the most significant dimensions, and explanations of each are provided. You have a coupling, two couplings, the shaft, axle, radial, and angular. Radial, the dimension of the measure of the outward of the center of the shaft of the plane perpendicular to the main axis on the shaft. The misalignment of the radial dimension, figure 2, mean with the difference position of the rotating axis of one shaft from a reference point where the two shafts are coupled together. The reference point is in center of rotation 1 of the shaft. So we have axle, shaft, angular, radial. Figure 2 shows the radial alignment, of radial displacement, and coupling. Axial with the dimension measured back forth along with the rotating axis of the axis. Axial misalignment illustrated in figure 3 means with the position of the whole shaft must be shifted in the direction its length with the dimension usually used for reference shaft thrust of the end bearing the shaft because of the offset position causes axle load on the bearing. Shows axial displacement. Angular, the dimension measured from the reference axle, center line, actual shaft of the coupling, rotating axis. Angular misalignment, figure 4. Refers to the angle on the one shaft makes of another shaft of the coupling interface. Note that the misalignment shaft may be radial or angular combination of both angle of misalignment, coupling, dial indicator. Most commonly used with the instrumental rotational alignment that work with the instruments, but the design is versatile with the possible with the actual application required with adaptation. Miscellaneous supports adapters can be obtained to suit individual requirements. Refer to figure 5. Some dial indicators read from 0 up to numbers such as 100. Some read plus or minus values on both sides of the 0. Refer to figure 6. Figure 5 shows usual typical dial indicator auxiliary support rod and adapter brackets. Chapter 6 shows the dial indicator set. Dial indicator sets are calibrated reading 1,000 of an inch. Maximum indicator reading refers to the highest reading plus or minus attained while performing measurement of the total indication reader or TIA. Total indicator reading is a whole change indicating reading discarding indicator reference. Shaft coupling and alignment. Couplings are used with the correct connect machine with the machine shaft. The machine shaft, the shafts coupling faces may rigidly bolted together, or they may have the rubber bushings between them. The variation of the coupling phase of the bushing design allow coupling to have some of the freedom movement and with the radial and or angular dimensions. In general, with each shaft of the coupled together, more than one bearing coupling must be used with this to tolerate some of the angular radial movement. This is necessary because of the difficulty in obtaining absolute alignment between two shafts carried in separate housings. Coupling has no radial flexibility, but some of the angular flexibility may be used with the coupling. One of the shaft is supported two or more bearings to another shaft with one support bearing. Note, even though a particular coupling can withstand some of this alignment, the shafts must be aligned as accurate as possible. Method of shaft alignment. The variety of the ways check for the measuring alignment of the two interconnected shafts with 3 different methods listed below, illustrated in figure 7, but the only last one 7C is recommended. A, straight edge thickness gauge. B, dial indicator micrometer. 2, C, 2 dial indicator recommended method. Straight edge thickness gauge is A, micrometer dial indicator. C, dial indicator methods of checking shaft. Procedures. Halves of the coupling must be bolted together before shaft alignment is performed. Refer to the applicable section of the publication contained with the torque value specific coupling. The recommended method: keep the two dial indicator rigidly attached to one of the coupling faces, usually on the driving shaft, with the measuring surface of the other coupling. Plunger one indicator plate with the parallel to the shaft with a button resting on the coupling face. The indicator button should be located with the face of the coupling distance beyond the coupling bolt, as close to the edge as possible. The indicator will read the angular misalignment of the coupling plunger, and other indicator were located against the edge of the coupling perpendicular to the shaft. This indicator reading radial misalignment of the coupling. So indicator plunger should be depressed one half or their total movement when they are being positioned. This allows for the indicator to measure the widest range of plus or minus values. After the individual indicators are applied, the coupling should be rotated with the indicator brought up to the top of the vertical position. At position, movable faces of each of the indicators should be set to 0. The establish the indicator reference setting from which the misalignment can be measured. An easy way to keep the track of the alignment readings is use two circles drawn on a sheet of paper. One circle to record angular measurement of the other radial measurement. The figure 8 of each circle graphically represents the physical position indicated relative to the coupling on the drive shaft. In this way, the vertical and top position is designed as 0 reference for the alignment procedure. The shafts are rotated 1/4 turn 90 from the reading of the both indicator reading. Indicator on the face of the back of the coupling show the angular displacement of the shaft. The angular displacement reading 0 with a full rotation of the shaft. The shaft aligned with the angular dimension. Usually there is some variation plus or minus values for each alignment operation. The indicator pointer move in the direction increases the number 10, 20, 30, etc. The reading record plus value. If the pointer move in the direction decreasing number 90, 87, the etc. The reading assigned with a minus value. The values are recorded with the circles as the shafts are rotated with the 1/4 turn increments. When the indicator has traveled a full circle around the coupling, both indicators should read 0 if they are returned vertical position. Both of the indicators do not return 0 for the reach of the original starting point. Then all the readings should be discarded, and the source of the error investigated, possibly one with the indicators not firmly positioned, but allowed to with a slight shift slightly change the indicator reference one of the region of the discrepancy is found with the corrective of the new setting. Readings must be taken. Typical set showing a reading is shown figure 8. Typical indicator reading shows at 0,000 of an inch, 3 plus or minus plus 3,000 of an inch, minus 10,000 of an inch, 4,000 of an inch on the left, 0,000 inch radio, 5,000 plus 5,000 inch radio, 0,000 of an inch radio, negative 0.5 thousandths of an area. The reading should maximize alignment, angular misalignment to 4,000 of an inch, maximum radial misalignment to 5,000 of an inch. Even though this is within limits established with equipment correction, could be attempted to reduce misalignment as much as possible. The readings example show that the vertical plane shaft needs adjustment, but it's not necessary to move the shaft up and down. However, the shaft is moved at the distance of 5 thousandths of a foot horizontally, 5,000 of an inch short of the side of the minus 5,000 inch reading with the total indicator reading of the radial misalignment should be reduced to 0, although this degree of alignment with a desirable attainable actual practice. Note the indicators usually fixed with the driving shaft will measure with the driven shaft. The correction of the angular misalignment are made with the moving one end of the drive shaft so that the entire rotating axis is parallel to the rotating axis of the drive shaft. Most alignment situations make it advantageous to correct radial and angular misalignment simultaneously. Circumstances may arrive with radial alignment of satisfactory angular alignment is needed with the correction of the means of shaft end being aligned is properly located with the remote end of the shaft that must be repositioned. If angular alignment is within specified limits, radial alignment is incorrect for the shaft to be moved in a direction perpendicular to the rotating axis. It must be moved at a distance equal. Highest positive of the dial indicator reading toward the opposite side of the coupling. Proper distance, the direction of the movement that can be determined through careful interpretation of the readings. If the piece of equipment is replaced with the replacement, should be mounted on with the original shims as starting point of the alignment process. Air compressor coupling alignment. The air compressor compressor drive shaft couplings installed with the coupling bolts torqued to 100 foot-pounds as shown in figure 9. To inspection require the line and check alignment over the coupling. The first inspection, the length of the measure for the distance between the coupling and the shaft. The second inspection, angular misalignment, which can be checked with either one of the two methods. First method employ the dial indicator, while the second method requires a feeler gauge. Length measurement, the distance mating faces of the 6 o'clock with the bound vertical position shown figure 9 must be held at 500,000 of an inch plus or minus 20,000 of an inch minus 0,000 of an inch for the application compressor coupled with the channel with the inner engine. Should be the room temperature of the engine crankshaft at the top. If the engine has been running, measurement will reduce maybe as low as 4,700,000 of an inch in respectively 490,000 of an inch respectively. Angular misalignment. Use the dial indicator. Angular alignment of the easel flexion number can be measured with the actual dial indicator figure 9 with a couple flange indicating against the face of the mating flange. Both indicators should be with the same plane. Check with the 2 couplings. Mount the indicator bracket. Set with the dial 0 with the indicator 12 o'clock position during the rotation shaft of the record with the indicator reading every 90 degrees. Angular misalignment must not exceed 20,000 inch indicator reading when the indicating point is not less than 10 inches diameter. Alright, show the driving coupler, the drive shaft of the driving coupler, indicator bracket, dial indicator, drive coupling shaft, assembly, drive coupling, compressor to engine application, compressor to generator application. User field guides, angular alignment of each flexible can be inspected by measuring the distance between the mating flange and the 90-degree intervals. 4 points, rotate the shaft with 180 degrees. Can measure 90 intervals. This reading takes 8 each of the coupling, must be within 20,000 of an inch of each other. Rubber bushing replacement. Air compressor driving the couples of figure 9 do not require the routine maintenance of lubrication. However, it is necessary if it is able to replace bonded rubber bushing with the need of the replacement evidence accumulation small rubber particles directly under the coupling. To facilitate the removal of the insulation rubber bushings, a puller tool may be used as shown in figure 10. The tool parts used with the opposite side of the coupling remove the insulation of the bushing. The insulation rubber bushings are small amount of the reed rubber lubricant should be applied with the leading press rubber edge of the bushing with the lubricant is mixed with the 3 to 5 parts of water before use. It should be stirred occasionally while in use. Other lubricants which are detrimental to the rubber bushing may be used. Note, after the bushing, installation is recommended at least 24 hours elapse before attaching the coupling. This waiting period is required to allow the rubber lubricant to dry. When the lubricant is still wet, the bushing can easily move it from its desired location. Bushing must be installed part of the doma location proper. Seat lips of the bushing. Bushing puller tool must be reversed and pushing at the bushing and moved until with a 470,000 an inch plus or minus 10,000 an inch. Dimensions shown in figure 11 obtained and maintain bushing face of the same plane. If the tool is not available, the press may be used. Show the coupling rubber bushing application gauge figure 12 is available to measure 400,000 of an inch plus or minus 10,000 inch dimension. The gauge consists of a triple leg base supporting lever indicator arrangement of the center to measure 487,000 inch plus or minus 10,000 inch dimension. Gauge position in large tripod. Legs rest on flange of the coupling and center of the actuating disc. Contacts metal center sleeve of the bushing inside of the locating prongs if the bushing is, and show the figure 10 show the rubber bushing puller tool application coupling removal of coupling installation. Figure 12 shows the bonded joints, bushing application, gauge scale, gauge pointer, rubber bushings. Properly located the pointer of the gauge with a light limiting scribe marks of the gauge scale. Calibrating fixture, the 3 calibrating disc, 460,000 of an inch, 470,000 of an inch, and 480,000 of an inch as part of the gauge to provide a check for the pointer accuracy. Large disc simulates for the coupling and the smaller disc are placed on the larger disc. The gauge is placed on the assembly to check with the pointer in position. Auxiliary generator alignment. For attempting to align auxiliary generator, main generator must be coupled to line with the engine. With the alignment with the auxiliary generator engine is divided in 3 parts. Thrust, finding the actual position, coupling with respect to the auxiliary generator drive channel and the auxiliary generator. 2. Angular, correcting angular auxiliary generator to drive assembly. 3. Radial, establish center alignment with auxiliary generator to the drive assembly. Bearing thrust alignment. The auxiliary generator axle alignment procedure of the different type of the auxiliary generator drive with assembly. These types are found with auxiliary generator drive with assembly application blower type of the turbocharged engines not having the same axle thrust dimension. 2. Auxiliary generator drive with assembly application turbocharged engines having a single axle thrust dimension stamped on the support housing. 3. Auxiliary generator drive assembly applications blower type turbocharged engine having the 2 axle thrust dimensions stamped on the support housing. Axle alignment procedure for the different type of the auxiliary generator drive assemblies are provided with an on-shaft of the drive assembly. 1. Pulling the drive shaft out of the engine. Take up the end plate with the drive assembly. 2. Assemblage mounting distance between coupling flange drive assembly and with the auxiliary generator figure 13. So with the dab of the correct distance against each of the coupling assembly. 3. Secure auxiliary generator to the frame. Install the coupling assembly torque coupling bolts to 100 foot-pounds of torque. 13. Auxiliary generator coupling measurement, mounting distance, drive shaft extended. Single stamp the drive assembly. Attach coupling shaft with the auxiliary generator drive assembly torque coupling to 100 foot-pounds. Subtract 50,000 inch number stamped on the supporting housing. Adjust position of the auxiliary generator to establish dimension. Figure 14. Show the stamp number less than 50,000 inch. Figure 14. Auxiliary generator drive with the bus management. No, only decimal portion following 4 over the entire dimension stamped on the housing at 4.260 thousand an inch would be stamped at 260,000 an inch. Secure auxiliary generator frame in the recheck with the measurement of the final thrust measurement between 20,000 and 80,000 less than stamped number. Double stamp drive assembly after a coupling shaft with the auxiliary generator drive assembly the torque the bolts to the 100 foot-pounds of torque. Adjust position auxiliary generator to the O. Obtain thrust clearance made midway between the two numbers stamped on the driving housing. Note: the shield of the drive assembly has been reversed to position coupled surface of the torque to the coupling to enable thrust measurement to be taken in feeler gauge and figure 15 shows auxiliary generator drive bearings clearing dimension between two stamp number to reverse shield secure the auxiliary generator frame in the recheck with the thrust measurement. The final thrust measurements must be between two stamp numbers. Radial and angular alignment. Radial angular alignment to determine assignment intensity with the dial indicator shown figure 16 with the dial indicator attached with the bracket. Shoe with the driving flange indicating button contact interface for the inside of the coupling housing. Figure 16 show the auxiliary generator drive coupling alignment. Set with the dial indicator 0 for the rotate the coupling 1 revolution. Turn of the engine crankshaft if the total indicator reading is within 150,000 of an inch maximum. The generator is considered aligned. Since any movement of the auxiliary generator affects the alignment, thrust, radial, angular alignment must be checked after each setting. Rubber bushings. Auxiliary generator coupling do not require any routine maintenance or lubrication. Rubber bushings are torn flange except for stiffness or cracks, and coupling assembly should be replaced. Do not replace just rubber bearings. Speed increase coupling. Speed increase the drive shaft couplings installed with the coupling bolts torqued at 230 foot-pounds of torque shown in figure 17. Shaft must be located taper bushing provided with the correct distance between the shaft flange and face speed. Increase flywheel when taper bushings hit. It's tight. Serve with the data specified within the model. Engine alignment. Angular alignment should be checked to each of the flexing member. The ash hatch dial indicator to the coupling flange indicated against the face of the mating flange. Angular misalignment should not exceed 20,000 inch total indicator reading with a revolving both shaft together. Rubber bushing. Speed increase coupling do not require any routine maintenance lubrication. Rubber bushings, the torn flange, excessive stiffness or crack for the coupling assembly should be replaced. Do not replace just rubber bushings. Alright, fan and pedestal alignment and maintenance performed in the switch locomotive with the requirement of the movie, the compressor for the distance assembly. The fan pedestal assembly will require any alignment to check with the fan with the pedestal assembly. The air compressor has been moved. It must be realigned with the final surface with the compressor drive sheave of the fan and idler sheaves over the fan pedestal assembly are in the same plane known as the 60,000 inch. The alignment can be achieved without distributing an alignment of the air compressors for the engine. It may be necessary to reposition the pedestal to accomplish the proper alignment. The maintenance required for the disassembly of fan pedestal assembly. Drive shaft should be measured in lateral movement between the inner and outer races of the bearing. Older switcher locomotives with a ball bearing support with the fan drive shaft with the combination with the attaching dial indicator with the pedestal with the plunger against the face of the fan drive sheath with the alternately push and pull should be within 100 pounds for the force reading with the total shaft move. The total movement should be within 5,000 inch minimum with the amount of the movement to indicate that the bearing is not preloaded with the condition caused for the improper assembly of the mounting. Shows for C server the data for the correct distance and show the speed increase driving coupling alignment. Newer switch locomotives have roller bearing one end and both ends of the fan drive shaft. The sheave end of the roller bearings have a 3/8 inch XL free play for the between the inner and outer race alignment. Consider the position drive shaft in the middle of the 3/8 of an inch actual free play of the sheave ends from the torquing down with the bearing and the fan. All aligned with the fan drive sheave and idler sheave at the same plane with the drive sheave of the air compressor within 60,000 of an inch. If this alignment cannot be achieved, it may be necessary to reposition pedals to accomplish the proper alignment. Tool generator to engine alignment and make an engine with the generator revolve true with the comparative of the free vibration alignment through the coupling must act exact in order for the generator to make correct and perform correctly with the electrical phase. The operation air gap between the main pole's armature rotor must be held correct dimension, evenly distributed in all holes of the generator, armature of the rotor, and in fact, the flywheel of the engine is joined with the engine crankshaft of the beneath with a flexible coupling engine coupling disc, and the generator coupling disc compromised with a flexible coupling. Each disc is mounted within center to the respective parts of the mounting bolts. The bolt of the disc is joined with a rim and other circumference of coupling bolts. Engine coupling disc rims of the degree of the marking around the circumference holes provided with an engine jack of the turning bar with a rotating crankshaft with a flexible coupling connect for the engine with the generator are basically the same in the minor difference of the construction incorporated with a provide specialized application create the interchangeable between modules. Current couplings have the V channel with the engine with the coupling disc with the V variation with the generator disc mounting bolt. Both rim and center have the clearance belt with the holes of the coupling with the design provides interchange between the earlier units with the body bound with the ream fit with the mounting bolts. However, the following recommendation should be adhered with the application serrated coupling. After installation with the generator coupling disc is made with the engine coupling disc and the rim bolts applied and properly torqued at 290 foot-pounds of torque. Coupling is then checked to travel the gap between the engine generator coupling disc. The rim bolts should not be less than 10,000 of an inch. Care should be taken to tighten all coupling bolts uniformly, avoid the cocking and the coupling of the deterioration. Recess indicator surface of deterioration. Coupling held the concentric with the center bore into rotating and some of the balance about the same center of the rim run out with the indicator surface measure out with the balance of the concentricity. It does not help with the outside rim and the coupling disc except with the fan pilot. Generators equipped with the fans, generator alignment, information alignment with the generator with the engine divided in three. Operational thrust find with the axle position, armature of the rotor with respect to the generator frame, angular correct with the angular generator engine coupling, radial balance and setting of the air gap between the generator armature and rotor and field poles, angular reading of misalignment and radial angular and radial alignment are carried out simultaneously. Generator bearing alignment after the generator is coupled with the engine vary with important looking with the generator frame axle. Avoid thrust slowly with the bearing with the either direction, bearing float with the toe play with each of the generators stand with the bearing cup with the end housing depending on the type of the generator. One, take all crankshaft thrust generator and engine prior to crankshaft door generator of the engine. This may be done by removing one oil pan handhold cover prying against the crankshaft with the web and crankcase A-frame. Locate the X measurement number stamped on the generator within half an inch numbers of the location indicated with the table. The one measure for the determined during the final generator. Some of the armature rotor depending on the type of the generator position. So the end plate is taken with the direction engine coupling. To remove the generator frame either away from and toward the engine to obtain the measurement of the total X measurement plus for the bearing thrust dimension listed in table 1. Generator alignment. Preparation of the power plant with the required with the generator armature of the rotor shaft of the generator frame and the bead in line with the engine crankshaft with the air gap to be equally spaced with the equally important with the eccentricity of the coupling is be held with the minimum of the directly affect with the balance bushing and the bear wearing air gap of the generator must be uniform with each of the main pole with as well with the uncommunicating pole with the edge from front to rear. Each pole with the obtaining the proper electrical characteristics of the generator. Since your generator has only one roller bearing with the recommended method lying with the air gap of the coupling of the engine end of the generator, radial, angular, misalignment alignment can be accomplished by even the tool indicator mounted with the support rod mounting position with the dial indicator will vary for the specific generator model. Figure 19 with the dial indicator location. Any generators equipped with the guard over the rotor must have the guard removed from before the applying with the dial indicator rod. Special indicator with the offset pickup of the arm will be required to permit rotation on turbocharged engines. One mount position dial indicator figure 19. Both of the dial indicators removed with the armature shaft. 2. With the engine turning jacket assembly flywheel should be determined with the show of the indicator rod with the vertical position. This will place both of the indicator near the top of the generator. 3. After clamping the indicator with the rod indicator buttons with the brought to the bear with the surface of them, they will arrive at the seat of the indicator depressing plunger for the half of the total of the travel to permit the indicator to show with the plus or minus reading of the coupling is rotated. 4. When the indicator is set, with the turn the flywheel of the engine turn but jack 180 degrees clockwise direction facing with the bearing end of the generator, rotate the flywheel 270 degrees counterclockwise direction with the counterclockwise rotation instead of the continued clockwise rotation is necessary to prevent indicator from striking the alternator terminal. If so equipped, as the indicator revolves around the generator, reading should be taken at each 90 degrees increment. The indicators returning the original starting point, but the should re-register 0. If they do not register 0, reset. Make another check with the replaced indicators is if defective. Alright, show the generator X dimension, measure stamp dimension, location, bearing, dimensions, inches, and thrust meters. If the AR10 D14 thin engine coupling, AR10 14 thick engine coupling, ARD 14 thin engine coupling, ARD AR10 D14 thick engine coupling, D32 D14 D32P D32S D32T D25C D25P D25R, D25S. Alright. Thrust alignment cross section. X measure shaft of this way, bearing and bearing. X measure the shaft of the always over this way, 116 to 364, so minus 164th of an inch. X measures shaft of the way. Note with the rubber compressing coupling is applied with a 5/32 inch X dimension measure for the compressing side, and that's D32P to S and T, D25P, C, P, R, and S. X measures shaft of the all this way. X. Check for checking air gap indicator, checking fuel angular alignment, engine flywheel generator coupling ARD 1014, thick engine coupling indicator, checking AR gap indicator, checking angular alignment, engine flywheel generator coupling, indicator of the front air gap, indicator for checking angular misalignment, indicator for air gap, indicator checking alignment, angular misalignment, indicator checking air gap, indicator checking coupling alignment. If the indicator readings are within limited shown in Figure 20 of the generator is considered to be aligned with the mounting coupling bolts be tightened to the specified torque. Since any movement of the generator frame affects both coupling and air gaps readings, both of them must be taken in each setting. Experience will indicate with the proper thickness of the bring the reading to the specified limit. Follow the length of shimmer should be used when possible for the spot shimmer to be necessary to conform to the limits. Upon completion, main generator alignment, the auxiliary generator must be aligned. Shows the indicator on coupling disc or inside surface fan 0,000 of an inch, 5 plus or minus 5,000 of an inch, plus or minus 5,000 of an inch. Stator housing 10,000ths of an inch. Figure 20 dial indicator alignment tolerances. Surface data coupling assembly number, mounting distance inches, millimeters, driving shaft number, shaft dimension, other drive faces inches and millimeters. Surface data, auxiliary generator coupling assembly, shaft dimension, drive faces, mounting disc, mounting distance, speed increaser, distance between shaft flange, speed increaser flange, flywheel, equipment list, bushing puller, rubber pull, lubricant, bush application gauge, gauge set, master, base plate, 46,000, 47,000, 46. 460,000, 470,000, 480,000, pointer calibration disc, dial indicator AR10 D14 only. Alright, and that was Electric Motor Division, General Motors Corporation Maintenance Instruction Alignment Locomotive Rotating Equipment MI 1753.